Hey, I'm back. I'm doing some more of these videos. So I'm back to do the last set of videos I'm going to do before Christmas. So I've got 3 videos in mind I'm going to do today, and then that'll be it before this year. And then I'll carry on in the new year, probably after like the 3rd or 4th. I'll be able to do some more videos if you want me to, or whatever else you'd like me to do. Obviously, during the Christmas period, I'll be in email contact, apart from the bank holidays. I'll be in email contact, so email me any suggestions you have, things you want to see. But this is the last step I'm going to do for this year, so just a couple of things I wanted to go over once again. So today I'm going to look at the example I did for Bayes' theorem and combining Bayes' theorem with probability trees, because I don't think I did a particularly good job of that in the lectures, so I wanted to just go through that once more. Okay, so where were we? Okay, so this was in section. This was Bayes' theorem. And the particular section this was in 1.2.2, which is about probability trees. Trees in relation to Bayes' theorem. So Bayes' theorem as it relates to probability trees. Okay, so the example question we had was the following. Suppose 2% of people are infected with some disease, so they're infected, and also there's a test that's been developed for the disease, and the test correctly identifies 99% of the infected, and the test gives a false alarm in 0.5% of the not infected. Okay, so the question is, given a positive test, what is the probability of the person genuinely being infected? Okay, so that's the question we're going to try and answer. Okay, God, my handwriting is awful. Okay, I'm going to try and neaten up my handwriting a little bit. Okay, so let's start. So now we're going to start our answer. Okay, so what we want is the probability of being infected given a positive test. Okay, so that's what we're looking for, and we have the probability of a positive test given you're infected, and that was 99%. And we have also got the probability of having a positive test given you're not infected, and that was 0.5%. Okay, so we can draw a quick probability tree, okay, for this situation. Okay, so we're going to have something like the following. Okay, so we have the probability of not infected, and down here we have the probability of being infected. And then from here, we have the outcomes of our test. So that's either going to be positive or negative. Positive or negative. Okay, so let's fill in the probabilities. So probability of being not infected. So we're told in the question that 2% of people are infected. So 2% of people are infected. We know this down here is 2. And this must be 1 minus that, so this has to be 98%. Okay, then we have the probability of not infected getting a positive result. So that's the false alarm case. So that's 0.5%. And that means the negative must be 1 minus this, so that becomes 99.5%. The probability of a positive test if you are infected, that is 99%. We're told that in the question. The probability of being of a negative test given you are infected is 1 minus this, so that's 1%. Okay, so the numbers that were given in the question are this one, and this one, and all the others are worked out just by doing 1 minus the probabilities. Okay, cool. So this is what we are trying to calculate. Okay, so now we apply Bayes' theorem. Okay, so let me just move the paper up a little bit. So we have Bayes' theorem. Bayes' theorem tells us the probability of infected given a positive test equals the probability of infected and positive divided by the probability of a positive test. Okay, great. So now we're going to calculate some of these quantities. So the first thing we want to calculate is the probability of infected and a positive test. Okay, so we just do exactly what you do from normal probability trees. We want probability of being positive and infected, so we just multiply across the probability tree. So 99 times 2%. Okay, so this is going to be 99% times 2%. That gives us straightforwardly 0.0198. Then we do the probability of positive, and this is where the probability tree is fairly useful, just to help you kind of make sure you get everything clear in your head. We just want all the probabilities of getting positive, so that can happen in 2 ways. Okay, we can get a positive test in 2 ways. Either we're going to get not infected and positive, or infected and positive, and we just multiply along the lines. 98 times 0.5% and 2% times 2% times 99%, and then we add those probabilities together. Okay, so positive is going to be the probability of infected and positive plus the probability of not infected and positive, and we just simply stick in the numbers. So we have, from before we had this number for the first case, so we know that's going to be 0.0198, and we add to that 98% times 0.5%, and we get a final answer of 0.0247. Okay, great. So now we can just stick these two numbers into Bayes' theorem and we get our final answer. So the probability of infected given positive equals 0.0198 divided by 0.0247, and we get 80.2%. Okay, so the test is actually a lot less reliable than it might at first seem. Okay, good. So I know that's a really straightforward example. I know that it's not very complicated at all, but you'll be surprised how often students get this kind of stuff wrong. And also bear in mind that some people in the course have not done any statistics before, or at least not since GCSEs. So some of this stuff is going to be new. So I hope that's really clear and easy to follow. If it's not, let me know and I can go through it again, maybe in more detail, answer your replies via email or the comment section on the website, but hopefully that's clear. Okay, I'm going to go on to the next video now. Thanks very much.